Hi everyone. As we continue to study about the weather, to get a better understanding, we need to see all of the factors that affect the weather. One of those factors is the air around us. Before we get started, let's watch a quick demo to see what's going on. Here I have an empty water bottle. You may say it's not empty because there is something inside of this bottle, right? There's air inside of this bottle. There's no water, but there is air. And I have a balloon that's connected to it, and you see the balloon is not inflated. And over here I have a pot of boiling water, and I'm simply going to place my bottle inside the boiling water, keep an eye on the balloon, and see what happens. Let's watch and see what happens as I place my water bottle into the boiling water. Well, would you look at that? Do you see what I see? The balloon is inflating. Now quickly I'm going to take this and place it inside of my ice water bath. Oh, did you see that? That was so cool. Had a water bottle filled with air. As soon as I placed it in the hot water, the balloon expanded. It was filled up. Then as soon as I put it in the cold water, it contracted. The balloon went back to its original size. What's going on here? Air. So cool. Hot air. As the air became hot, it actually expands. Expands means to get bigger. As it got bigger, it took up more space. Then, as soon as I placed it in the cold water, it started to cool down. Now, it took a little bit more time for it to cool down, as we saw, but eventually all of the air cooled back down to the room temperature, and the balloon was deflated again. Let's do another demonstration to see if we can see this a little bit clearer. What I have here is another water bottle. Again, empty except for the air that's inside. And I have all these lines to measure. And right now we have room temperature air inside of here. What if I were to heat up the air that's inside of this bottle? Well, how can I do that? A kettle filled with boiling hot water. I'm gonna pour a little bit in here and just move it around. This hot water is actually heating up all the air. As the air is heating up, it's expanding. And what I have here is ice cold water. You may say it's blue because I've just colored it blue with food coloring just so that you could see it better. Now what I'm going to do in just a minute is pour this water out because I don't need it anymore. And the only thing I'm going to be left with is hot air. And let's watch and see what happens. Can you see it? Do you see the water level rising inside of the bottle? It's going up. What's going on here? What happened as soon as I poured the water out and placed my bottle inside the ice cold water? Look at it. Look how high it's going. Well, I had put hot water in here. That hot water was heating up all the air, and that air was taking up all the space. It had expanded. Then as soon as I poured the water out and flipped it into ice cold water, well, the ice cold water it's cooling all of the air in here. As it cools the air, well, what does the air do? What does cold air do? It contracts, it becomes smaller. As it became smaller, well, there was more room in here, and that room cannot stay empty, would create a vacuum, made room for the water to go up into this bottle. So cool, right? Hot air expands, cold air contracts. In the last demo, we were able to see how much air contracts. Now let's see if we can measure how much air expands. I have a bottle here that's just filled with air. This is a bottle filled with blue food colored water. And this is our measuring bottle. Let's see if we can measure and see how much the air expands. I have my coffee pot here, and I have some very hot boiling water. And you can see all of these bottles are connected with my straws, have some clay in place to make sure none of the air escapes. I'm going to pour boiling hot water into this coffee pot, and let's see what happens to the bottles. Did you see that? How cool was that? We saw that as I poured in the boiling hot water into the coffee pot, that heat heated up the air inside the bottle. And what happens to air as it heats up? It expands. It needed more space. It needed more space, and it had nowhere to go but up through the straw, down to this straw, and into this bottle. And all of that extra space pushed through this straw down and caused the water to come out the other way and get transferred into this bottle. Hot air expands, and we can measure and see. Look at how much it expanded. That's a lot. We can actually see air expanding and contracting. For today's lab, we're going to need some materials from our enrichment bag. You're going to first take out this piece of paper that says the gas trap. You will need to provide scissors, plastic cup, and some kind of a lid to go on the plastic cup. I'm just using a paper plate. You will also need to provide some hot water and make sure you have the assistance of an adult nearby. The first thing you're going to do is using your scissors, very carefully, you're going to cut along the dotted line and cut out this rectangular shape. Put this to the side, and this is what you're gonna need. Now that you have this piece of paper cut out, I wanna see if you are able to read these words and what is the last sentence that you can read. Can you read all these words through your cup? Maybe you can, maybe not. To find out, try it and see. The last line that I can see says, to find out, try it and see. So I'm going to record that on my paper. The next thing I'm going to do is take my boiling hot water and very carefully pour it into my plastic cup, a little bit less than halfway, and then quickly place the lid or whatever cover you have for it. Now you're going to take your piece of paper again, and now you're going to place it behind your cup and see if you're able to read the words. Now be honest and try to read and record the last line that you are able to read. Now we're holding the piece of paper above the water line, not below. Now as I hold my paper here, I really cannot read any of the lines. I'm trying, I know what the words say, but if I'm gonna be really honest, I cannot tell what any of the words say. Take a minute and record the last line that you can read. If you can't read any of the lines, like me, just write, I cannot read any of the lines. Now what I want you to do is look at your cup really, really closely. Look at the side of the cup. What do you see? Tiny, tiny, tiny little droplets. Do you see those? I can see it really clearly. Take a minute and on your sheet, in the little circle, draw what you see. What are these tiny little drops? And more importantly, where did they come from? Well, there's water vapor in the air. When that water vapor comes into contact with a cold surface, like the surface of the cup, it turns into drops of liquid water. So the water evaporated, came into contact with a cold surface, and turned back into liquid water. Now, the last thing that I want you to do is very carefully take your lid or your plate, whatever you have off. Just put your hands in the upper portion of the cup and tell me what it feels like while you're touching it. Touch the lid, the plate, whatever you may have. And you can actually see it. What does it feel like? Go ahead, record your results. So inside of my cup felt moist and warm. And the bottom of my lid, or my plate in this instant, also felt very wet. For the second part of this lab, you're gonna have to go into your enrichment bag again. And this time you will need the sponge, a pipette, and from your home, you'll need to provide a cup of water, paper plate, and some napkins. Now I'm going to add pipettes of water to my sponge, one pipette at a time, and I'm going to record that number and measure and see how many pipettes does it take to saturate the sponge. Once the sponge is saturated, it will start dripping from the bottom. Let's see how many it takes. So that's 1. And you'll see the sponge starting to expand. This is a sponge that had no air in it at all. That's 1 pipette. 2. 3. 4. Try the other side too. 5. 6. 7. 8. 9. No dripping, we're not saturated. That's 10. Make sure all of the water goes onto the sponge. I missed a little bit right now. It's 11. And a really good trick is to hold it at an angle from the corner like this. And let's keep going. It's 12. 13. 14. 15. 16. Feel it getting heavy. 17. 18. 19. 20. 21. 22. Still not saturated. 23. 24. And look, what do you see? After 24 drops, it is dripping away with water. 24 pipettes is what it took to saturate my sponge. Go ahead and try this on your own and see how many pipettes does it take to saturate your sponge. Let's talk about this sponge for a minute. So I told you this sponge is kind of like a model for a cloud. As the water evaporates, it goes up into the clouds, it condenses into the clouds. Once the clouds become full enough, when those water droplets become heavy enough, then we see precipitation. And what is precipitation? Rain, snow, sleet, hail, all different types of water falling from our sky. Let's just recap everything that we did today. We did a lot. We learned about air. We learned about hot air expanding, cold air contracting as air becomes hot, it gets bigger and takes up more space. As the air cools down, it condenses and takes up less space. We also learned about our air containing water in the form of water vapor. Sometimes we call that humidity. You may notice an area is more humid, less humid. Maybe you'll notice curly hair gets a little bit curlier in humid weather. And we also learned about precipitation, how water falls from the clouds. Water condenses into clouds. And as the water condenses, it becomes heavy enough that water falls due to the force of gravity. That's right, gravity is the force that pulls the water, the snow, the hail, and the sleet down. We learned all about weather today. Go ahead and try these experiments. Make sure to fill out your data sheets. And I can't wait to see what your experiments look like.